Hi students, good afternoon. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall do the section 5.2 homework assignment. Section 5.2 homework deals with probability distribution. So we want to make sure that we have read the notes. Let's get on my website. You can just go to my mobile friendly site, Samuel Chukwu Emeka AppSpot. And you go to mathematics, statistics, notes. So before you do the 5.2 homework section, it is recommended you have finished probability and you have also read probability distribution. I'm going to open up probability distribution. We might need it. That's the note. So it's recommended that you have read the notes on probability and probability distribution and viewed the videos as well before you do the homework. As usual, we are going to use technology to do this homework assignment. We shall be using the Pearson Statcrunch and my calculator as usual. Important things to note in probability distribution, we are looking at a discrete variable that has some values, and they also give us the probabilities of those values. So you have a discrete variable that has some values, and you're given the probabilities of the values. So two things to note. One, the sum of the probabilities of the values of that discrete variable should be equal to 1. When you add all the probabilities of the values of the discrete variable, it should give you 1. The second thing is that the probability of each value of that discrete variable should be between 0 and 1. As we learned in probability, 0 is the probability of an impossible event, an event that can never occur. The probability of an impossible event is 0. And the probability of an event that must occur is 1. 1 is the probability of an event that must happen. So, the probability of each value of the discrete variable should be between 0 and 1. Okay, so the two things, the sum of all the probabilities of the values should be 1. The second thing, the probability of each value of the discrete variable should be between 0 and 1. Okay, let's begin. Question 1. The table to the right lists probabilities for the corresponding numbers of girls in 3 bets. What is the random variable? What are its possible values? And are its values numerical? Numerical means numbers. So the random variable is the number of girls. That's the random variable, and that is a discrete random variable. with the discrete random variable, you can count. You can count them. If you can count the variable, that means it's discrete variable. So these are the values here, and these are the probabilities of the values. This tells us that the probability of having no girl is 0.125, 12.5%. The probability of having one girl is 37.5%. The probability of having two girls is 0.375 or 37.5%. And the probability of having three girls is 12.5%. You want each value, the probability of each value is between 0 and 1. So we are good with that. Now, let's now add, I'm going to get calculator real fast. Finder, applications, calculator. So let's add all the probabilities, 0.125 plus 0.375 plus 0.375 plus 0.125, and that gives us 1. So the two conditions are satisfied. So if you look at this here, the random variable is x, not p of x. So b and c are out of the way. Okay, b and c are out of the way. We eliminate b and c. So let's look at the a and d. Random variable is x, which is the number of girls in 3 beds. That's right. Possible values are 0, 1, 2, 3. Okay, values are numerical. Yes, numerical just means numbers. Okay, so the answer is A. And you can press the enter key. Okay, next question. Determine whether the value is discrete, random variable, continuous, or not a random variable. So discrete, you can count it. Continuous, you can measure it. That was one of the first things we learned in statistics. Square footage, you measure it. So it's continuous. You measure, you don't count. You measure the square footage. Weight, you measure weight. You measure weight. So is a continuous random variable. You measure weight. Eye color is a qualitative. Okay, it's qualitative variable or categorical variable. So we don't regard it. Is the eye color of people on commercial aircraft flights. We don't regard it as a random variable. It's qualitative variable or categorical variable. Qualitative, not quantitative. Number of hits to a website, you can count it. You don't measure it, you count it. So you count it is discrete. It's discrete, random variable. Okay. Distance is the distance a baseball travels in the air after being hit. Distance, you don't count distance, you measure distance, right? You measure it. So if you measure it, it's continuous. Okay. Number of people with blood type A, blood group A. The number of people, you count them, you don't measure them. So you count it, it's discrete. Okay. Question 3 is similar to it. Number of statistics students now doing their homework, you count them, you don't measure them, so they are it's discrete. Yes or no response is not a random variable. It's not. Okay. Weight of a hamburger. Weight, you measure weight, so it's continuous. Number of light bulbs that burn out in the next year in a room with 11 bulbs. You count it, so it's discrete. Number of textbook authors now eating a meal. You count them. You count the authors. You don't measure them, so it's discrete. Number of home runs in a baseball game. You count it, right? Discrete. Okay, so here is where we can now use technology. Question 4. 5 males with a particular genetic disorder have one child each. The random variable X is the number of children among the 5 who inherit the genetic disorder. Determine whether the table describes a probability distribution. If it does, find the mean and standard deviation. So first of all, let's find out whether it describes a probability distribution. I'm going to pull up that calculator. Where did it hide? See where it. Okay, so just I can add this up without a calculator, but to save time, let's just do that. So we're going to add the probabilities. The value of each probability is between 0 and 1. So that's good. So that condition is satisfied. The next one, let's add up all of them. 0.0255 plus 0.138. 138 and 1380 is the same thing. Plus 0.299 plus 0.324 plus 0.1755 plus 0.038. So that gives us 1. So this describes a probability distribution. Now let's find the mean and standard deviation. So let me do this first with my calculator, then the next one we can do with Statcrunch. How about it? Some ones we do with Statcrunch, some ones we do with my calculator. So these are not a lot. So because my calculator shows the steps, when you go to the notes, you look at the steps on the problems I solved here. So you have to look at this is the formula, and you look at the steps to solve it. Okay, that's the notes which I believe you should have gone over before you do this video, before you do this assignment. I want to use my calculator because it shows those steps. So I'm going to go to resources and I will go to probability distribution calculator. Okay, click on it. So the probability distribution calculator, I actually want to have this side by side. So let me just open another browser. Let me go to Safari and then go to Google, and I just type in, I want to have this side by side. And actually, you can also go to portfolios. I can go to portfolios and get it. And I'm going to probability distribution calculator. So I want to have this side by side. So you can kind of see it. I'm going to I want you to see it like how I'm putting it in. Okay, this is the homework here. So this is the one, finding probability distribution. If you were taking this in class, if you were not taking this class online, uh, if you were taking this course in class, your professor might want you to show all your work. So your professor will want you to show these steps. Like the way I have it in the notes, I have x times p of x. Okay, if you look at these notes, x times p of x, you see that. Your professor will want you to show all your work. So he wants to see this, then to find the standard deviation, to also see this. So your professor might need these steps. So when you're solving it, sometimes with calculator, if you don't get the answer right, then this calculator will help you to find out, okay, what did I do wrong? But let's go ahead and do this. We have 0, you put a comma, 1, 2, 3, 4, 5. And the probabilities, we have 0.0255, comma, 0.1380, comma, 0.2990, comma, 0.3240, 0.1755, and then 0.0380. And calculate. So these are the steps here. Why I'm using my calculator is because also you will easily see if you didn't get the answer right, you can figure out whether you got the steps right. Like I said, if you were taking this class, this course in class, your professor would want you to actually do it as a table, to solve it as a table. You see, x times the p of x, then you have x squared, you have x squared times p of x, to kind of solve it as a table. So before you get the mean and standard deviation. So this calculator would explain if you messed up in any step, assuming you didn't get the answer right. So you can fix that step. Okay. So our mean, round to 1 decimal place as needed. Our mean, now I've explained as needed before. As needed means if it is only 1 decimal place, you put it to 1 decimal place. If it is more than 1 decimal place, then just round to 1 decimal place. So we see that our mean is 2.6. 2.6, okay? And then the standard deviation, our standard deviation is 1.1. 1.1, okay? 1.1. And that's it. The next one, you can add this. Ted is not particularly creative. He uses the pickup line. If I could rearrange the alphabet, I'd put U and I together. The random variable x is the number of girls Ted approaches before encountering one who reacts positively. Well, determine whether the table describes a probability distribution. If it does, find the mean and standard deviation. Okay, where did that calculator hide? Okay, it didn't hide in this section. Probably hid in this section. Okay, So let's get this calculator and see. This question is kind of funny. All right. 0.002 plus 0.019 plus 0.133 plus 0.258 plus 0.325. Let's do it again. 0.002 plus 0.019 plus 0.133 plus 0.258 plus 0.325. Okay, the sum of all the probabilities is not equal to 1. So because it's not equal to 1, because it's not equal to 1, this is not the table is not a probability distribution. So the answer is B. Okay. Find the standard deviation. This is not a probability distribution. If it is not, then you just say it's not. You don't waste time solving the rest. Okay, question 6. In the accompanying table, the random variable X represents the number of televisions in a household in a certain country. Determine whether or not the table is a probability distribution. If it is a probability distribution, find its mean and standard deviation. So click the icon to view the data. This is not too big, so I guess I'll still use my calculator. Don't worry, I'll teach you how to use Statcrunch. I will do that. So I have 0, 1, 2, 3, 4, 5, 6. 6. I put 6. No, that's not 6. I'm sorry. 0, 1, 2, 3, 4, 5. Okay. And then the P of X is what I'll change. I have 0 0.03, comma. Actually, let me go ahead and reset this. It's always good to reset it. 0, 1, 2, 3, 4, 5. No comma. Do not put a period or comma at the end. Just type the probabilities in decimals only. So here you have 0 0.03, 0. First of all, let's add all this first and see what it gives us. 0.03 plus 0.15 plus 0.23 plus 0.28 plus 0.17 plus 0.14. So it gives us 1, so we're good, okay? We are good. So 0.03, 0.15, 0.23, comma, 0.28, 0.17, 0.14. Calculate. So the mean is the mean is 2 point to the nearest tenth. Nearest tenth is 1 decimal place. So the mean is 2.8. 2.8. Okay. And the standard deviation is 1.3. 1.3. Okay. Question 7. Groups of people aged 15 to 65 are randomly selected and arranged in groups of 6. In the accompanying table, the random variable X is the number in the group who say that their family and or partner contribute most to their happiness. And this is based on a survey. So this is, we can just, let's use Statcrunch on this now. Let me show you how to do this with Statcrunch. But let's go ahead and add this. This means that the probability is, 0 actually. for this particular case. But let's go ahead first and add it. Let's add it. Okay, I'm trying to. This keeps hiding. You have 0, which 0 is there, 0.019 plus 0.025 plus 0.199 plus 0.243 plus 0.322 plus 0.192. So this gives you 1, okay? This just means this 0, okay? Let's go ahead and do this. I'm just gonna come here. I can actually come here, put 6, and then I come here 0, 0 0.019, 0 0.025, 0 0.199, 0 0.243, 0 0.322, 0 0.192. Okay, calculate. Okay, so this is the mean 4.4, and this is a standard deviation 1.2. This one decimal place. So the mean is 4.4, and then standard deviation is 1.2 if you round it to one decimal place. So it's 1.2. 1.2. Okay. Question 8. Let the random variable x represent the number of girls in a family with 3 children. Assume the probability of a child being a girl is 0.45. The table on the right describes the probability of having x number of girls. Okay, determine that. And then, is it unusual for this? Okay. First of all, let's find out whether it is a probability distribution. Just add this 0.166 plus 0.408 plus 0.334 plus 0.092. Okay, so this is the probability distribution. All right. Let me just reset this. 0, 1, 2, 3. And I have 0.166, 0.408, 0.334, 0.092. Calculate. Here they said we should put to 2 decimal places. So the mean here is 1.35, 1.35. Okay, and the standard deviation is 0.86. 0.86. Okay. Is it unusual for a family with 3 children to have only girls? The family with 3 children is this. Okay, and the probability is 0.092. If when we did probability, we say if the probability of an event is less than 5%, then that event we say is unusual. It's an unusual event. Let's get to my notes. Let's get to my notes on probability, and it is in the notes. Unusual event, because this is under probability. Unusual event, in general, But depending on the situation, yeah. If the probability of an event is less than 5%, then we consider it unusual event. But this is, it depends on the situation. In this particular question, uh, this is 9.2%. So it's not unusual. Okay, this is 9.2%. For unusual event, if it's less than 5%. But in this case, and like I said, the unusual event, it depends on the situation, which we discussed under probability. So here is 9.2, so it's not less than 5%. So it's not unusual, no. So we look at we eliminate options A and B. We look at options C and D. No, because the probability of having 3 girls is should be greater than 5%. Okay. Question 9. The accompanying data table describes results from groups of 10 bets from 10 different sets of parents. The random variable x represents the number of girls among 10 children. So, yeah, this is big. Typing all this here, okay. I can still type it, but let me show you this. Let me show you this with Statcrunch, okay? But let's look at the question. It says, use the range rule of thumb to identify a range of values containing the usual numbers of girls in 10 bets. What is the maximum usual value? Okay, the maximum usual value, you find it in z-scores. So let's get back to my notes. Let me actually delete this here. Let's get back to my notes, statistics notes, and look for z-scores. Z-scores. We're looking at the maximum usual value and the minimum usual value. So maximum usual value is the mean plus 2 times the standard deviation. Okay, mean plus 2 times standard deviation. So we have to first of all find the mean and the standard deviation. Let me get that calculator because I'll need this. I'm gonna need this, so let me get it. So this is how you get, let's find the mean and standard deviation. But in this particular question, let's use Statcrunch. These like big data. But if you're still solving it to show your work, you can still use my calculator. This is going to give you the same answer. So you click on this icon here, click to copy table, click on it, and click open in Statcrunch. With Statcrunch for probability distribution, you want to go to Start, you go to Calculators, you go to Custom Calculator, Custom. Okay, you go to Start, point at Calculators, Custom. But like I said, if you have to show your work, then this is the way to go. My calculator is the way to go to show all your work. Okay. But this is just teaching you also how to use Statcrunch. So here the values are the x and the weights are the probability. Okay, P of x. Put that. And click compute. So it gives you the mean and the standard deviation. Okay. So and we say that the maximum usual value is this. Maximum usual value is mean plus 2 times standard deviation. Okay, so where is that? Hit here. See how this is hiding. See how it's hiding. So we need mean plus 2, mean plus 2 standard deviation. And they want it to 1 decimal place. So this is what we're going to do, folks. Let's close this here. Because they want it to 1 decimal place, the final answer to 1 decimal place, let's have intermediate calculations to 3 decimal places. Okay, so this is 1.733. So 2 mean plus 2 standard deviations, remember. So 2 times the standard deviation, 1.733. Or let's use the whole thing. Okay, let's use the whole thing. 1.7329097 equal to. Please don't use 1.7, please, no. When the final answer is 1 decimal place, so make sure your intermediate calculations, you round it to like 4 decimal places. Round it to about 3 more. Or just don't round at all. I would say don't round at all. Do not round intermediate calculations. Do not. Okay. Use it as is. Is the final answer that you now round to the number of decimal places they want you to do. Okay. So this is 2 times the standard deviation plus the mean. So this is we've multiplied that, then plus 5.032 equal to. So this is 8.5 now. We can now round to 1 decimal place. And this is 8.5. Okay, 8.5. So we put 8.5. Okay. Actually, if you want me to, I probably might think about doing that. I can also put it in my calculator. Maximum usual value, minimum usual value. I can do that. I can do that. But, well, I might or I might not. It depends. But programming is nice. It's nice. I did this with JavaScript, a scripting language. And of course, I'm a web designer, so. Okay, the minimum usual value is this. The minimum usual value is mean minus 2 times standard deviation. So let's just do this. 2 times the standard deviation, 1.7329097. Okay. So this doesn't have memory. If it has memory, it would have been better, much more better. But you can use your calculator, okay? And this is, you subtract this from 5.032. It's not going to be a negative, but at least you understand what I'm saying. You subtract it from that. So the answer is actually 1.6. 1.6. You subtract from that. Okay. Based on the result, is 1 girl in 10 beds an unusually low number of girls? Explain. The range of the usual value is between 1.6 and 8.5. That's the usual value. Okay, so 1 is out of the range. 1 is out of the range. So we say it's unusual, yes, because 1 is out of the range. So it's gonna be S. So we eliminate B and D. So yes, 1 girl is an unusually low because 1 girl is outside of the range of usual values. Yeah, it's out of the range. So yeah. Question 10. The accompanying table describes results from 8 offspring P's. The random variable X represents the number of offspring P's with green pods. Okay, let's click on it. So it didn't, in this question, it didn't ask us to find whether it is probability distribution or not. So we're just gonna, we're gonna take that it is, okay? Find the probability of getting exactly 7 P's with green pods. Well, it's here, right here, exactly 7. So this is 0.316. 0.316. Okay, 0.316. Okay. B, find the probability of getting 7 or more P's with green pods. Okay, so 7 or more is 7 and 8. 7 and 8. So we just add this. Where's that calculator? We just add this. 0.316 plus 0.092. And that gives us 0.408. 0.408. Okay. Then it says, which probability is relevant for determining whether 7 is an unusually high number of P's from green pods? Well, if we are looking at that, we know that it's 7 or more. Okay, so it's actually the probability from B. Okay. Is 7 an unusually high number of P's with green pods? Why not? Use 5% as the threshold for an unusual event. So 0.408 is 40.8%. It's more than 5%. This 0.408 is greater than 0.05. So because it's greater than that, it is not unusual. No, it's not unusual. So we are eliminating options A and C. We're looking at B and D. It's greater than that, so it's not an unusually high number. So D. Okay. Question 11. The accompanying table describes results of roadworthiness tests of cars that are 3 years old. The random variable X represents the number of cars that failed among 6 that were tested for roadworthiness. Find the mean and standard deviation for the number of cars that failed among the 6 cars that are tested. So let's click on this icon. Let's go ahead and do it with Statcrunch. I'm just going to close this one here. So click open a Statcrunch. Go to Start, Calculators, Custom. Values are the X, number of cars that failed. Weights are the probabilities. Compute. So the mean is 1.256. 1.256. Okay. Okay, the mean is 1.256, but they say round to 1 decimal place. Don't mind me. You see, you get to pay attention. So the mean is 1.256, round to 1 decimal place, so that would be 1.3. Okay. And the standard deviation to 1 decimal place is 1.2. Okay. Next question, question 12. Based on data from a car bumper sticker study, when a car is randomly selected, the number of bumper stickers and the corresponding probabilities are as shown below. So, does the given information describe a probability distribution? So let's get our calculator. Let's add all these. 0.787 plus 0.094 plus 0.035 plus 0.029 plus 0.015 plus 0.014 plus 0.009 plus 0.007 plus 0.006 plus 0.004 equal to 1. Cool. Okie dokie. Yes, it is. Yes. Assuming that a probability distribution is described, find the mean and standard deviation. Click here, open in Statcrunch. Start, calculators, custom. Values in X, weights in P of X. Compute. So the mean, round to the nearest tenth as needed. So the mean is 0.6. 0.6. Okay. And the standard deviation is 1.5. Round to the nearest tenth as needed. So this is 1.5. Okay. Use the range rule of thumb to identify the range of values for usual numbers of bumper stickers. So maximum, what is that calculator? So 2 times the standard deviation, 2 times, we're using the whole thing, okay? Because the final answer we have to round to 1 decimal place. So let's, intermediate calculations, let's use the whole thing. 2, or even if you don't use the whole thing, that's fine, but let's use the whole thing. 2 times, okay, 8 plus 0, 8, okay. So now I can 5 times 2, 10, okay. 2 times 1.4619767 equal to, then maximum, okay, so plus 0.568, and that is 3.5. I can actually just close this table. And then the minimum, let me just do here, minus 0.568. So this is what the 2 times that gave me, okay? Now, then I do minus 0.568, 2.4. Do you guys understand what I did? Ooh, so the minimum, we do 2 times 1.4619767, okay? That should be mean minus that, minus 2 times standard deviation. So let me just do minus 0.568, mean minus 0.568, 2 times 1.4619767 gives me this. Okay, so I'm gonna put this minus this, okay, then I do plus 0.568 so that I get that. So this is negative 2.4, negative 2.4. Okay, negative 2.4. Because that's the way I can do it. Okay, but this can never be less than 0. Okay, so we have negative 2.4, but then we are talking of bumper stickers. That's true. We're talking of bumper stickers in this case, and the number of bumper stickers is a number. It's not going to be less than 0. So you can't have a negative number when you're talking of number of bumper stickers. So we'll just put 0 here. We'll put 0, okay? Is it unusual for a car to have more than one bumper sticker? When we're looking at more than one bumper sticker, let's get back to the table. You add the best way to have more than one bumper sticker, okay, is 2 and above. 2 and above. So let's add all these probabilities. But an easy way to do it is we add this to the probability of having 0 bumper sticker and 1 bumper sticker, and then we subtract, because the question says to have more than 1 bumper sticker, which means 2 or more. Okay, 2 or more. So let's add this 2 and subtract from 1. So we do 0.787 plus 0.094 gives us this. Now we subtract from 1. I'm going to just put this, and then I do plus 1 equal to. So 0.119. 0.119 is greater than 0.05. Okay, so is it unusual? It's not unusual because if it is greater than 0.05, it's not unusual. 0.119. So this is a B. Okay, because it says more than 1 bumper sticker, which means 2 or more. So you can add up all these. And it will give you 0.119. But what I did was, since this is the probability distribution, the sum of all the probabilities is 1. So I just added this first 2 and subtracted from 1. Okay. Okay, so this gives us that. Question 13. Assume that 12 jurors are selected from a population in which 50% of the people are Mexican Americans. The random variable X is the number of Mexican Americans on the jury. Find the probability of exactly 7 Mexican Americans among 12 jurors. I'm gonna close this here. So this is the probability right here, 0.193. Okay, 0.193. 0.193. Okay. Find the probability of 7 or fewer Mexican Americans among 12 jurors. So we're gonna add 7 or fewer. We're gonna add all these. So we have 0.193 plus probability for 6 Mexican Americans. Having 6 Mexican Americans in among 12 jurors is 0.226 plus 0.193 plus 0.121 plus 0.054 plus 0.016 plus 0.003, okay, plus 0, okay. So this is 0.806. And actually, you see this question, I did this question here. I think I did an example of it here. Yeah. Yeah, this is an example of it. I did here on the notes, in the notes. Okay, I did an example of it in the notes. So, what did we get? We got a 0.806. Okay. Which probability is relevant for determining whether 7 jurors among 12 is unusually low? Is it the result or from part A or part B? So it's the result from part B. Okay, it measures the probability of 7 or fewer successes. Yeah. Okay. Continue. Is 7 an unusually low number of Mexican Americans among 12 jurors? Why or why not? So the probability is 80.6%, which is greater than 5%. Okay, so it's not. No, because the probability is greater than 0.05. Yeah. Question 14. In a state pick 3 lottery game, you pay $1.42 to select a sequence of 3 digits from 0 to 9, such as 3 to 2. If you select the same sequence of 3 digits that are drawn, you win and collect $422.66. Complete pass A through E. I did an example like this. I would like you guys to actually look at this example and do this question, or do you want me to still do it? Because my main thing is to teach you how to use technology, and I think I've done that. You look at this here, the number of different selections. Actually, if I'm looking at this from my example, I can still do it. Let me get this here. Command C and get it here. Command V. So I can look at it side by side. I can actually close this here. So I can kind of look at it side by side and do it if you want me to do it. My main purpose of doing these videos is for the technology side. But whatever I've done as examples, I expect you to like look at the way I did it and then you do it. So this is 0 through 9, okay? So, and it's 3 numbers. So it could be 1,000. This is 1,000. Okay, later you read it. And if you have questions anytime, please do ask. Okay. Probability of winning is 1 over 1,000. That's the probability of winning. Over 1,000. Probability of winning in this case 0 to 9 consists of 10 digits. probability. What is the probability of winning? The probability of winning is 1/1000, but they want you to type an integer or a decimal. Because if you type 1/1000, 1/1000 is not an integer. Okay, 1/1000 is not an integer. So you just do 1 divided by 1000. That's 0.001. Okay, 0.001. If you win, what is your net profit? Yeah, 1/1000 is a fraction. It is not an integer, it is not a decimal. So they want you to type an integer or a decimal. C, if you win, what is your net profit? So the winning amount minus the amount to play. So 422, where is that calculator? So 422.66 minus the amount to play is 1.42, $1.42. So that is $421.24. $421.24. Okay. Find the expected value. Expected value is the mean. The mean of the probability distribution is the expected value. So let's see here. If you win, we would have, if you win, they lose the, if you lose the game, that is you lost the amount you used to play, which is $1.42. But if you win, you multiply the amount you win by the probability. Okay, so 422.66 divided by 1000. 422.66 divided by 1000. If you multiply it, okay, so it gives you this. And then the money you used to play, assuming you lose, that's minus 1.42, $1.42. Okay, so the expected value is a negative. That's almost $1. It's actually negative 1.00, almost $1. So negative 1.00. Okay. So if you bet this, if you bet $1.42 in a certain state's pick 4 game, expected value is negative $1. Which bet is better? $1.42 bet in the pick 3 game or $1.42 in a pick 4 game? You do pick 4. If you pick 4, that would be 10,000, right? So if we pick 4, where's that calculator? Why did this calculator hide? Where did it hide? Okay. If you pick 4, it will be 422.66 divided by 10,000. If you pick 4 numbers, okay, and then you assuming you win, okay, this is the probability. This x times p of x, okay, the probability will be 1/10,000. So 0.042266, which 0.042266. I didn't want to write, but I think I'm going to write now. So just write that down. Write that down. 0.042266. You write it somewhere, like I'm writing 0.042266. And then, assuming you lose it, it will be uh, it will still be negative that. So we just subtract actually 0.042266 minus, assuming you lose the game, then you lose the amount to play, minus 1.42, and this is negative 1.38, $1.38. So which one has a larger expected value? If you pick 3, it's just $1 that, the expected value is losing $1. You pick 4, the expected value is losing $1.38. So the pick 3 is much better. Okay, it's much better. Um, question Question 14. In a state pick 3 lottery game, you pay $1.22 to select a sequence of 3 digits from 0 to 9, such as 455. If you select the same sequence of 3 digits that are drawn, you win and collect $434.49. Complete pass A through E. I did an example of this question in this note. So let me just copy this, Command C or X. Let me copy it, Command C, and I'm gonna come here and paste it, Command V, and I'll just close this right here. I'll close it. I close that. I did an example like this here. The number of different selections. The number of different selections. This is, you pick 3. That will be 1,000. Okay. What is the probability of winning? Type an integer or a decimal. So probability of winning is 1 over 1,000. But they want us to type an integer or a decimal. So I'm just going to type a decimal. Because 1 over 1,000 is a fraction. It is not an integer. It is not a decimal. But the decimal would be 0.001. Okay, 0.001. If you win, what is the net profit? Net profit is winning amount minus amount to play. What is that calculator? Where did that calculator hide? There you go. So the net profit would be the winning amount minus the amount to play. So this is $434.49 minus amount to play $1.22, and that is $433.27. Okay, so 433.27. Find the expected value. The expected value would give us this. You multiply the amount by the probability. So the expected value is actually the mean of the probability distribution. So I'm gonna do 434.49 divided by 1,000, because you multiply by 1 over 1,000. So this is 0.43449, and the amount to play. Okay, assuming you lose the game, you just lose the amount to play. So this is minus 1.22. So the expected value is you lose 79 cents. So negative 0.79. Okay. If you bet $1.22 in a certain state's Pick 4 game, the expected value is a loss of 79 cents. Which bet is better? A $1.22 bet in the Pick 3 game or a $1.22 bet in the Pick 4 game? Well, they said it here that if you bet $1.22 in a certain state's Pick 4 game, the expected value is still the same thing. So whether you bet 3 or bet 4, now if they didn't give us this, then you have to calculate the expected value. But they told us that even with a certain state's Pick 4 game, the expected value is still a loss of 79 cents. Okay, so neither bet is better because both games have the same expected value. Okay. Question 15 is now fill in the blank. A dash variable is a variable that has a single numerical value determined by chance for each outcome of a procedure. That's a random variable. Excuse me. A dash random variable has either a finite or countable. That's discrete random variable. Okay. A dash variable has a dash random variable has infinitely many values associated with measurements. That's the continuous random variable. In a probability histogram, there is a correspondence probability histogram between the area and the probability. Probability histogram. So the area of the histogram corresponds with the probability. Area and probability. Question 19. If under a given assumption, the probability of a particular observed event is extremely small, we conclude that the assumption is probably not correct. This represents what? It represents the rare event rule. Okay, rare event rule. Question 20. The dash of a discrete random variable represents the mean value of the outcomes. That's expected value is the mean. I just said it. I said it a few minutes ago, or a few seconds ago. Expected value. Okay. All right. Thank you so much. I think we finished it. Thank you so much for listening to this video session. If you have any questions, please feel free to ask. And you have a great day. Say